All right, so hello everyone, and welcome to today's another exciting session with another exciting judge of the Space Science Challenge. I hope that you all are loving this entire series, which we are bringing and learning something new and getting to know more about the industry and getting an idea about how you can go ahead and work on your project and getting some tips from the judges themselves and on the path to win the Space Science Challenge 2022. All right, I can see that there are a lot of you who have already tuned in. So let me see that if you guys are there or not, or is the number glitching in front of me? So if you guys are here, just go ahead and write anything, maybe like, hey, boom, yo, what's up? I'm excited. Let's go. Anything, any emojis are also fine to see that, okay, the numbers, whatever is there on my scene, they are correct numbers and LinkedIn or YouTube is not bluffing me. All right. So let me see that in the comment section. And till the time you guys are doing that, because yes, I know that there is a bit of a lag between what I say and it receives. So let me just quickly pull up our special guest of the day, which is Miss Monica Ekal. So Miss Monica Ekal is a PhD candidate in the space robotics at Instituto Superior Técnico, Portugal, researching on the dynamic uncertainty reduction in free flying space robots. Her background is deeply rooted in space robotics. She's skilled in robot estimation, trajectory planning, and control, and she has 4 years of experience in designing aerial and space robot algorithms. She has worked on Swiss Federal Institute of Technology in Lausanne and Massachusetts Institute of Technology. Her work has also been tested on NASA's Astro B robotic platform on board the International Space Station. And she is your judge in the space robotics category of the Space Science Challenge 2022. So, thank you so much, Miss Monica, for agreeing for this live session. And thank you so much for being a part in the Space Science Challenge 2022.
Well, thank you for having me and thanks for the opportunity. I look forward to what projects our student teams have come up with. And yeah.
All right. So thank you so much for that. So, as I'm aware that you're currently a PhD candidate and you're researching on dynamic uncertainty. Firstly, for the audience, could you just go ahead and explain a little bit about what is dynamic uncertainty in free flying space robot? I mean, what exactly your PhD research is about, and also when are you getting your doctorate? That is another question.
Yes, sounds good. So, what I'm researching is something called dynamic uncertainty. And this is related to on orbit servicing. I'm sure most of our audience has heard of it. So, on orbit servicing is this way of trying to make space more sustainable, that is, to try to repair any satellites on orbit or try to refuel them. Or so this is one category which is repair. There is another category which is assembly. So suppose you want to assemble something on in space, so, how to get robots do these things? Or just transporting payload, or just tasks like these inside the space station or alongside crew. And what happens usually in these servicing tasks is that there is a target satellite and another satellite, a chaser, or there is a satellite which interacts with an object. Let's say you are doing on orbit assembly, and then you have to transport this component from the deployment location to the assembly location. So every time you come in contact with another spacecraft or another object, then the properties or the something that we call inertial properties, which is mass or inertia or the center of mass offset. So all these properties change, right? Because when there's one body, it has one mass, but then suddenly you have two bodies that are connected. So then all these properties change. And then this means that the dynamics of the system also change. So this is something that I'm trying to research, like how could we try to uh, let's say combat this. So either try to estimate what are the new properties, or either try to have control systems that operate and we get our task done in spite of having these uncertainties. So globally this is called dynamic uncertainty. And yeah, as you mentioned, I am researching control and estimation methods to try to combat these effects. And yeah, I mean, I'm currently writing my thesis, so fingers crossed, hopefully I'll be finished in by the end of this month or next month. Yeah.
Oh, by the end of this month or next? Okay, Just
Pretty
okay. That
close,
that's
yeah.
yeah. That's pretty close. Okay, we can't have. I mean, yeah, we are pretty excited for your doctorate and all the very best for your thesis. And okay, that is phenomenal. Whatever you explain, I think so. Basically, in a nutshell, yeah, to make the to make space more accessible, sustainable, reduce all the uncertainties, make it more, what do we say, foolproof. I believe that is what we are researching about, right?
Right. So yeah, it's essentially to make things more robust so that anything goes wrong, hopefully our system can still handle it. Yeah.
All right. So yeah, I think yeah, I think I understood. All right. So okay. So yep. So you have gained so many diverse experiences, and you are currently doing your PhD. So could you mind just telling us about your journey in the space sector? How did you step into the space sector? And maybe from your childhood, what inspired you to maybe get into space and do what you are currently doing? How did you gain that first? To maybe maybe any movie, any astro, whatever you think, or with your journey in the space sector.
Yeah, so I think my answer would be the same as a lot of people growing up in India. It was Kalpana Chawla, just watching her, hearing of her, and the tragedy of the Columbia spacecraft. That was really something that stayed with me, even though I directly did not take action upon it. So I have a bachelor's degree in electrical engineering, and then I went on to do robotics, and then I worked with drones for a bit. And then I accepted this PhD position to work in space robots. So this is my PhD that I'm doing right now. And that was really my entry point into the world of space through robotics. And yeah, I mean, since then I've had a bunch of different learning experiences, as well as this opportunity to really collaborate with MIT in Boston, and then to test our work on the space station with Astrobee, which is a free flying robot that NASA has made. And then we got to put or upload our algorithm, our code on this robot, and then see how it performs in space. So that was really the highlight of this PhD. Yeah.
Okay, that's pretty great. You talked about Astrobee and a bunch of other things. We'll loop back to those as well. We'll be looping back to Astrobee about the algorithms. So yep. So I'm looping back to there as well. So before I move forward, guys, if you have any questions for Miss Monica, please go ahead and mention them in the chat section. We will pick up each and every question in the chat, and yep. So we'll cater to your queries, as that is the main intention of the conduction of these live sessions. So feel free to drop your questions in the chat section, guys, and we shall be picking them. All right. So okay, perfect. uh, and all right, so since you are currently in space robotics, and that is what we're discussing about, so can you please go ahead and explain to our audience what exactly do you mean by space robotics and how important it is for space exploration?
Right. So I'd say, just to globally describe space robotics, it's similar to robotics on Earth, right? So we want to automate something, and I'd say it's more important in space because of all the dangers involved in it. Like, it's better to send a machine to go and check for us how Mars is, to try to get some samples back before we can prepare our crew, our astronauts, to go there. So I'd say space robotics is just a kind of automation that we do in space. And I mean, the type of space robots, I divide them broadly into categories. So let's say one of them are ground robots. I mean, not ground robots, I should rather say planetary robots or rovers. So this is
Okay.
something that we are all familiar with, like the Perseverance rovers. So rovers, just these robots that are deployed on the surface of other planets, and then they send back information about how it is there, send back samples, how the atmosphere is, things like that. And another category would be free flying robots or manipulator robots. So these are robots are they really boil down to having a spacecraft in orbit and having a manipulator, so a robotic arm on top of the spacecraft to do certain things, like the ones I mentioned before, like assembly or refueling or deorbiting, so things like that. So I'd say these are the two broad categories that we can put all robots in, all space robots, sorry, in. And why is it important? Well, like I mentioned before, I think it's our best shot at really trying to go further and further out into space in, the earliest possible, because it's a logical first step, right, to send robots to prospect the terrain. So just considering the example of Mars, so that we learn more before we can train our crew to go there. And then it also makes sense to have robots go and kind of set things up, like if we want to deploy a habitat for the crew to eventually go and live there, so then we can have robots to lay the groundwork for our crew to make their work easier. And I mean, also because it's it's cheap as compared to training crew.
Yep.
It's cheap, and it's also very, very less dangerous, right? Because it's okay if something happens to a machine, but we need to make sure that our crew is absolutely safe. Even though that is no excuse to make bad machines, yes, but even then, so that's I'd say that's it's like a simulation in a sense, that we have a robot that we think would work perfectly in that environment, and then we analyze how it goes, and then we say, okay, then we can send our crew. And then I think another reason would be like just considering the assembly scenario or the on orbit servicing scenario. These satellites that we have that are causing all the debris are really
Right.
in higher orbits, right? So then
Right.
it doesn't make sense to train crew to go there and to fix those things, which is why you see a large number of companies, and even NASA is interested in this on orbit servicing issue, because this is a problem that we need to solve, and having spacecraft to do this is a much better solution than really sending humans out there to solve this.
All right. Yep. That. Um. I mean, that's exactly the main objective of creating all these space robots and sending them to. Yeah, mainly for the space exploration part. That is what we are looking for. That is what we are designing them for, and a bit about solving the debris problem as well. A bit, yeah. So we are also working on that as well. So yep. So those are all the things which we are working for, and that is how important space robotics is. All right. So since you've given us a lot of explanation on what has happened or what is currently happening in this industry, so could you please go ahead and maybe give a few innovations which has happened in this field? Some maybe not, I wouldn't say in 2 3 years, maybe like a decade or two before any innovations which has happened in this field.
Sure. I mean, this question I'd like to kind of divide it into two categories, right? So, one is if we talk about space agencies or companies,
Yep.
where this is also something, like I mentioned before, this is a topic that has been gaining a lot of interest. So, a lot of startups or a lot of space companies are doing missions that haven't been launched yet, but will be soon, let's say in this decade, to try to have a proof of concept of on orbit
Okay.
servicing. So there is this, for the interested audience, there's this OSAM mission that NASA has been working on for a while, and that is supposed to grasp a satellite, to put it in the right orbit and refuel it and do all of this in space. So this is really a proof of concept of how we could do on orbit assembly in the future. And at the same time, there are many other space startups or companies that are doing similar projects. So this, I would say, this is really the closest that we've come to seeing these things work out and seeing these in action in space. And it will happen over the coming decades. So there are companies like Orbit Fab, which are doing on orbit refueling. Then there is, I believe, there's Maxar Technologies, who are developing robotic arms to help in these kind of servicing applications. So yeah, a lot of innovation is happening in this field. So very interesting times ahead. And the second part I would say is researchers like me, right? So what we are trying to do is we are really trying to generalize this whole problem. So not considering that we know a certain satellite that we want to deorbit. Let's say there is any generic satellite that we want to deorbit. So how can that be done? So one example is, let's say, using computer vision for observing a target satellite and trying to predict, okay, how is it moving, where would it go next? So problems like these. So these are more general. So we are trying to really make this problem more robust, and this is what this whole community of space robotics researchers is trying to try to get scientific, to do really more hypothetical scenarios and to try to find solutions for those.
All right. So yeah, Piyush is also agreeing. He's also saying the space robot is a crazy idea, and the people who are developing are more crazier. So, but yeah, crazy things are necessary in this field, and the more crazier the idea is, you can say that yep, that is how, or what do we say? Yeah, we are proceeding, or we are going into the future. Like maybe 50 years back, mobile phone was a crazy idea, but see what it has brought us to. So yeah, all crazy ideas are good, I would say. I mean, most of them are good. Yeah, most of the crazy ideas are good. So yep. All right. So well, thank you so much for explaining all the recent innovations which has happened. And yep, uh, right. So whatever we had seeing, and what and you said about Maxar Technologies as well. We had another session with yeah, we had another session on Maxar Technologies where um, we had one of our judges who was also explaining the same thing what Maxar Technologies is currently doing. So yep, our audience are aware of what exactly it's happening, and yep. Connecting all the dots, we can see that how all the companies, irrespective of their domains, are still contributing towards the main area, that is space exploration or space sector. That is what we are mostly
Exactly.
contributing towards. All right. Perfect. And all right. So thank you for answering that questions. And so basically, your main expertise or your main work is in free flying robots. So can you please explain, or can you please give a few examples of what are free flying robots, and how they are currently assisting us or currently assisting the astronauts?
Right. So free flying, this whole concept of free flying is something that is a little bit technical, but I'll try to explain it. So normally there are two kinds. So there's free flying and there's free floating. And
Okay.
if we put a manipulator arm on a spacecraft, and we, let's say that's the robot that we are working with. So if we are moving the arm and controlling the base, which is the spacecraft, at the same time, that means it's a free flying. And what happens in free floating is that we just move the arm and we don't care about what happens to the base. And the whole reason we have this problem is because of something called reaction forces, which we don't have on Earth, right? So on Earth, let's say we have a ground robot, we move the arm, the robot base doesn't move. But in space, you move the arm, then the robot base moves in reaction. So this is the reaction forces, and that makes all the difference. So consider that you are doing a task which is very safety critical, and you have to do it very precisely. So in that case, somebody would choose to do free floating mode, because you don't want to keep controlling the base and then have the arm move in response and then try to potentially collide with the target. So for something that is very precise, and if you're very close to the target, then you would do free floating. But otherwise, anything in space is mostly free flying. That's how I would categorize it. And the robots, some examples would be, so consider you have the Canada arm on the ISS, and at that time it wouldn't really make a difference, because the Canada arm, even though it's huge and it's heavy, it doesn't really create a lot of effect on the space station. So we do keep controlling the station at the same time that we move the arm. But the kind of robots that I work with are really experimental platforms. So these robots are inside the International Space Station, and some examples are Astrobee from NASA. Then there is this robot called Simon from DLR. Then there is Intball, a robot from JAXA. So as you can see, a lot of space agencies are interested in these, having these free flying robots as test platforms on the space station. And these are not, I mean, yes, they operate in microgravity, but they are inside a closed space, right? So they are not just let out in space yet. They are inside microgravity, and the whole, because they are test beds. So what exactly are we testing, right? So we are testing algorithms of the type that I mentioned earlier, the assembly algorithms or the payload transportation, to see how exactly it works in microgravity, like what are some unexpected things that pop up when suddenly you take gravity out of the equation, and things like that. So yeah, these are some of the examples, and as you can see, there is a growing interest in having uh, testing stuff just to prepare for the future.
All right. Well, thank you so much for answering that question about free flying robots. And yeah, and for the people who have joined in just now, guys, if you want to ask any questions, feel free to write them in the chat section as well. And yes, we are also having a space robotics internship. You can work on these such crazy ideas as well. And Dr. Shreya Chantra would also be leading the same thing. So, yeah, feel free to do that also. And also, along with that, yeah. So, Miss Monica, you explained about two types of robots, and one the base is moving, and the second case the base is not moving. So, for the base to not move, how do you make sure that the base is fixed? Do you attach it to something, or
No, so the punch here is not controlled. So what
okay,
happens is in free floating, you let the base move, but you don't hold it in position.
okay,
Right, so let's say you have a robot and an arm. So the arm, you move the arm and the robot moves in response. So you let the
okay,
base move, you don't control it. Whereas in free flying, you also want to maintain the position of the base as well as the arm. So you have to anticipate the reaction forces and make sure that you apply the inverse control so that the base stays in the position that you want it to, as well as things, the arm does the things that you want it to. So you see, it's a little bit of a complex problem. And well, welcome to the world of space. Yeah.
yeah, welcome to well the space. You remove gravity in the equation, and you are in a different realm altogether. Well, literally, you are in a different realm, I would say, if you remove gravity from the equations. All right. So, I mean, that is what I was thinking. That how do you control the base? Okay, so you let it float. Oh, that's great. Yeah, that works well. And till my job is doing all right. And yep, okay. So you've also answered my other question. That is how Canada Arm is also helping in the International Space Station as well. All right. So okay. So we've explained about all the rest of the things and what exactly are they and the different kinds of robots. So are there, or could you please go ahead and list down a few challenges in developing the same in developing a space robot? What are the ways challenges you face? I think one of them would be remove gravity from the equation. That is major challenge, I would say. But yeah, please go ahead.
Yeah, I'd say it really depends on the application. So, for instance, if you want to build a manipulator robot, so then you have to make sure that the arm, and we can talk about the Canada arm again as an example, right? So,
Right.
the arms of these robots are really hollow. They are like pipes, but they at the same time, it makes sense, right, to have something like this because in gravity, you without gravity, I'm sorry, you can carry more payload, you can carry more load. So the arms do not need to be really heavy. So the arms are usually hollow and then they are long enough that you can, and it again, it depends on the application. So for the ISS, you need to reach different places. So then you have a really long arm and then you can transport whatever object you want on top of it. So that would be one application. Another one is, let's say you have a rover, and then that how you design it would really depend on the planet or the body that you want it on. So, for instance, if you wanted to send a rover on an asteroid or on a comet, it wouldn't really be something like the Mars rover because I you wouldn't have as much gravity for like something to really operate on wheels there. So, for instance, I think there were a few JAXA missions on, I think it was called Ryugu, one an asteroid, and these robots that they send there are really robots that hop on the surface of the asteroid, so they do jumps. But even those jumps have to be precise because if you jump too high, you can just escape the gravity of the asteroid and just go out into space. So that's one thing. Like the design and the propulsion mechanism or how to make the robot move really depends on the application, the environment you are in. So, for instance, talking about the free flyers that I work with, they are supposed to operate inside the space station. So that means you
Yeah.
have a constant airflow. You're not you're not in vacuum. So those robots are they work on the same principle that we have drones here on Earth. So they have fans to to push air out so that the robot can maneuver. So then that again is an example of the environment that you are in and how you would make the robot move. So I'd say that is the main thing to think about, like what's the environment, and based on the application, what should the propulsion system of the robot be. And otherwise, there are a lot of other things that you need to take into account, like will the robot be exposed to radiation? How to protect that? Will there be, if it's a spacecraft that's out in space, how to protect it from the heat? And so this is like I think this was sometime in the Apollo missions that they kept the orbiter rotating, like, they kept it slowly rotating so that each face would be exposed to the sun equally so that one face wouldn't heat up. So we
Uh,
have solutions like these to protect it from all the harsh factors that you come across when you go out in space. And then there is also tiny particles or tiny debris that might hit it. So how do you protect the robot from all of this? So yeah, these these mechanical factors really need to be tested. So I'd say these would be the two main important points, like how to make the robot move and how to protect it from all the harsh aspects of operating in space.
all right. Well, perfect. Thank you so much for explaining that. All the various challenges which we face is radiation is one is the challenge, and I think basically the major challenge would be the uncertainty or the unknown factor. We don't know what we are stepping into, so that is, I think, the major challenge which we face, right? The unknown factor.
Right, yeah. I mean, even after accounting for things, there are chances that things might not go right. So, for instance, there have been cases like the, I think it was called the Rosetta mission. So, this was the mission that was a collaboration by the European Space Agency. So, it was supposed to go on this comet, and it so happened that it could not land properly. So then it didn't latch on to where it had to, and then it could not land properly. So then the scientists had to think about, with whatever remaining days we have, because the robot cannot, it cannot turn its solar panels to get enough sunlight. So whatever battery we have, whatever days we have remaining in the mission, how do you get all the science and all the data that you have? So yeah, so this is also like, even if things go wrong, how can you still fulfill at least some of the mission objectives before before everything stops working. So there's always, like, there has to be a plan B, C. Yeah, it's yeah.
All right. Thank you so much for that, for answering that question. All right. So, all right. Okay. So we have, all right. So you have told us about the basic challenges which you face in designing of the space robot. So as you were explaining that we were, or we do take into consideration all of the various factors. So how do you exactly test these robots before you send them to space?
Yeah, I'd say there are 3 to 4 options. The first one would be to do all the material testing, right? So I think this happens everywhere. So let's say you have a satellite, then you would test it for vibration, for heat, for thermal test, etc. If it's going to survive the launch from Earth to orbit. So these things come first, the material testing really. And then once you've built the robot, tested that all the individual equipment works, so all the sensors, the camera, everything works fine, then you have the whole robot. So how would the robot and its algorithms perform in microgravity? So that is the second major part, I would say, microgravity testing. And then for that you can, this is one kind of approach that you can take. So you test it on the ground on a flat surface like an air hockey table, where, so of course the robot cannot fly, but it can rotate and translate on the ground. So this is one, so table testing. The second would be to do one of those parabolic flights that where you have the arcs and you have microgravity for 40 to 45 seconds on every down arc. So that would be one way. Even though it's seconds, it's still microgravity. So that's one way. And then of course there's the ISS, right? So at this point there is that's the only option, but there are some other space stations being built, like Axiom is building one, so that would help more teams test their work in space. And there are also companies who are launching experiments in space, and I believe Spaceonova has also done or is going to start the astrobiology thing. So
Right.
yeah, so there are so that's great actually, and there the more opportunities are opening up for people to test their work in actual space environments. Yeah.
Right, right. Yes, and that is exactly correct. And yes, we are launching an experiment in space, an astrobiology experiment. Yes, we are launching them in space. Yeah, it's still time, but yep, we are going towards that as well. Yep. All right. So thank you so much for explaining how do we exactly test these robots. I was pretty much interested in how do you test the microgravity, but yeah, okay, it's a nice idea. And the parabolic flights are always there where not yeah, 40 seconds I think is enough. Even if we need more, then it can go up again and then come down again, so we would have another 80 seconds of microgravity. That's more than enough for us for collecting the data whatever we get and see if our robot is performing all right or not. All right. Okay, so thank you so much for answering that question as well. So you've explained about how these testings are done, but I believe that we can also go ahead and do a simulation of these robots where we can go ahead and build an URDF and same test it on to simulation softwares using ROS and Gazebo as well. So do we get any differences or do we observe any differences in these simulations and when they are in actual space?
Definitely. I think this is something that's very common if you're working with robotics, that things that work in simulation don't work in real life, even if it's on here on Earth. And one of the main reasons for this not happening is uncertainty, because in simulation it's really not possible to precisely model every effect that you would see, to precisely model sensor noise, environmental noise. Let's say you have a drone, and yes, you can model the amount of wind that would that you would experience while flying, but then that means that the robot can only operate in those conditions. So if it
Uh-huh.
has to operate in other conditions, so then it makes sense to simulate for a number of different wind speeds and things like that. So uncertainty is, I would say, a number one problem. And yes, it also comes up in space. So for instance, for an example out of my work was that we tested our work in simulation, and when the same work was tested in space, there were a few different problems. So one of them was, of course, sensor noise, which was much more than we expected. Then one of those was that there was some drift that we hadn't modeled in the simulation, so that was causing a problem because the algorithm did not work as expected because of this drift. And then there's something called a localization system, which is to see where the robot is exactly. And for that we take in information from a bunch of different sensors. Sometimes we do sensor fusion to combine data from different sensors to precisely find, okay, maybe the robot is here. So that also needs to work. So if, especially specifically in my case, if the localization isn't working quite well, then that also causes problems. So so definitely there are differences, and I'd say the number one is just all the uncertainty that exists in the environment. And it's not even possible, like it doesn't make sense to expect that things in simulation and things in real life will have the same outcome.
All right, but I believe the simulation does give us a good idea if we are maybe making any choices between like two kind of designs of a robot and maybe testing on different terrains. I think at those instances simulations are pretty great, right?
Yeah,
Mm-hmm.
definitely. I think it's like an excellent first point to test everything and see how it works. And that's it's exactly like you mentioned, right? So if things go wrong in simulation, it's just simulation. If there are collisions, it's fine. You can fix things. So that is a test that you should definitely be passed before doing going on to hardware. So yeah, it's very important. for sure.
All right. So, well, that gives us a good idea of what we are currently doing. Yeah, and we cannot always expect that whatever we are seeing in simulation. I mean, yeah, it's not. Yeah, I mean, we cannot even expect that it should be the same. Simulation is a very well controlled environment. And putting into space, all the control gets thrown out of the window. So, yeah, we cannot expect the same thing to happen as well. All right. So, thank you so much for answering that question as well. And guys, if you want to ask any questions, please go ahead and do so. I don't see any question in the chat section as of now. Yeah, you can definitely go ahead and mention any questions you have, and we'll definitely cater to them. All right. So, I think another major question which the audience would have is that can you please tell us some various career opportunities in space robotics which we are having?
Yeah, it's a growing field. I wouldn't say that there are a lot of opportunities, but it is a growing field, and more opportunities will pop up for sure. So it all comes down to having the right skill set that these kind of missions need, right? So even if it's somebody who's working in robotics and they want to get into space, then it's possible. So let's say you want to program a space robot, or you want to work on the localization or control or uh, estimation, so things like these. So it's it's different aspects of robotics that also need to be applied in the space robotics uh, applications, let's say. So what the kind of opportunities that you would get would be similar, is the point that I'm trying to make. And how to do that is not really, I mean, it depends on luck as well. So the best part here, however, is that there are a lot of companies who are doing private missions, and those are only going to increase. So the space market, the space robotics market actually is expected to grow by a lot. And the only problem here is that most of it is in the US or Europe. And however, I still say that the good point is that we have a lot more startups coming up in India, and there is also private sector investments which are growing. So yes, the opportunities are increasing, and for the students who are interested, I would say to keep an eye out for not only for opportunities but also for a match in the skills that are needed, right? So what skills do I have now versus what would potentially such kind of missions need, and what how I can find a correspondence between them, or if there is something that's missing, how can I improve their, let's say, coding, let's say design, um, yeah, just mechanical construction of robots. So you can also say that's design, or writing algorithms, what kind of propulsion systems they need, so things like that. So I think it's that's the first advice that I'd give to somebody who's interested, is to find what else I can do to try to be suitable enough for these kind of opportunities that come up. Yeah.
All right. Well, okay. Thank you so much for answering that. What are the some career opportunities? And yes, it is expanding as you have said. And if I recall correctly, according to a recent survey which has happened, it has been predicted that by year 2027, the entire the market size of space robotics is going to be more than 4 billion US dollars. I think that has been
Exactly.
expected. By just 2027, we are going to be seeing in just less than in about 5 years, it's going to be more than 4 billion US dollars. So that is how tremendous the growth is currently. And if you want if you want understanding, so maybe in 2022 the market size was about $2 billion. So now it's just $4 billion. It's just doubled, and then the growth is always exponential, as we all know. So yeah, we are growing quite fast. And yep, that is something great about that. So since you have explained as well some what are the ways career opportunities, how can anyone get started in space robotics?
Right. So I like I mentioned before, it's it all comes down to having what's needed for working in this field. And if you are interested, then for sure to try to find the skills that you can improve upon. So that would be one. And then second, if time permits, try to do projects on your own or related to or find a team, like find a group of people, participate in the SSC, so do, yeah, try to work towards this goal. And it doesn't have to be something, uh, it doesn't have to be something that takes up all of your time. It's fine. It's just, you just need to speak the language, so as to say, quote unquote, to know what where the industry is going towards. So like I mentioned, so for on orbit servicing, this is something that's increasing, right? So what are the terms that are used, what are the current problems, and how can the skills that I have be used or be required in the future to solve these kind of problems.
All right. So, well, and a follow-up question just about that would be, as you said, that you can participate in the Space Science Challenge. Any advice for the participants of the Space Science Challenge?
Yeah, I'd say it's I'd say to try to use this opportunity to sample kind of the field that you are interested in. So let's say if a team is interested in satellites, or they want to know what is done with all the satellite data that you get, so then try to choose a project related to that, try to read up on what's happening, and use that information to shape your idea. That would be one of my suggestions, to try to get a feel or get a glimpse of how it is to work in that domain. And that would also help to make your ambitions a little concrete. So, okay, this is how it feels, and if I really want to do it. Another advice that I would have would be to keep the momentum going. So, let's say you did a project, you enjoyed it, and then try to find more projects, try to find like minded people, and you never know. I mean, a lot of this is also dependent on luck. So, you never know what might click in the future for you. So, that would be something that I would definitely recommend, to try to keep the momentum going, to try to find something related to space, to keep working on reading, talking to people. And then, I mean, don't forget to have fun, right? Because interpersonal skills is something that I feel is sometimes undervalued or underrated. So because if you have a great idea, it's also important to present that idea well, so that you can convey your thoughts to people. So yeah, just make friends and make contacts and try to have fun.
All right. So, yep. All right, everyone. So have fun, and I hope that you are enjoying the Space Science Challenge, all the rounds which we are bringing you guys. That you're enjoying all these, and hope you are having fun, learning something new. And all right. So, all right. So I think we've almost come to the end of today's session. And before we conclude today's session, any book or movie which inspires you the most to pursue your dreams? Any recommendations which we can also watch or read?
I've been always a fan of any movies that are about space. So, and I'm sure a lot of the audience likes movies like Interstellar or Gravity. They are really inspiring. Apollo 13, and a book that I would definitely recommend, and I also mentioned this the last time, was An Astronaut's Guide to Life on Earth by Chris Hadfield, who is this Canadian astronaut. He's retired now, I believe, but
Right.
it's his story that I find very inspiring. That he started off when Canada did not have a space program, and he still wanted to be an astronaut, and everything he did was keeping that goal in mind. But at the same time, he had a plan, saying that, okay, if the astronaut thing doesn't work out, at least I'll be doing something that I like. And this was something that still continues to inspire me, and something that I would definitely recommend people to read. It's so he takes in all the experience that he has had from going to space twice, and to try to uh, condense it into how people like us, who might, how people like us can actually use that advice to continue working towards our goals, even if we don't want to be an astronaut. But even for, yeah, even for regular people, let's say.
All right. Well, okay. Thank you so much for that suggestion. And yes, you did mention that in the previous slide session as well. An Astronaut's Guide to Life on Earth by Colonel Chris Hadfield. Right.
Yeah.
That was the book you have recommended. So yeah, we'll definitely check that out, and I believe the audience will also definitely check them out. So guys, in case you have any questions, feel free to write them in the chat. If not, then with this, we have come to the end of another live session. We are expecting another live session very soon on the 20th of July with Mr. Anirudh, who is our judge in the rocketry category. So for rocketry guys, bonus another session for you all. That is with Mr. Anirudh. So that is about the next one. Okay, so we have a question by Satya Silan, who's saying, okay, all right. So, what is the best programming language currently used in the aerospace robotics? Okay, yeah, basically, yeah. What is the best programming language to use for space robotics?
Yeah, good question. I'd say it depends. If you are working more on the robotics side, so in robotics currently C++ is used widely, and so robots like Astrobee, the one that I worked on, because it was built by people who had a background in robotics, they also took C++ out there. So C++ and ROS, a robot operating system, is this communication framework that
Right.
Astrobee uses. But at the same time, I'm sure that languages such as C or Python, or if the robot is was built a little bit in the past, then maybe some of the older languages. But for sure, C++ and Python would be two languages to watch out for and to try to stay on the top of. Yeah.
All right. So, one question, I think C++ is an older language, Python is a newer language, right? So, I believe that the newer robots should have Python rather than C++.
No, I mean C++ keeps updating, so you
Uh,
have the rules of how to use C++ or the new functionalities keep getting added every few years. So I believe currently it's 21, and then at 23 there's going to be another one. So they keep updating. So by 21, I mean 2021. So they keep updating the C++ framework based on new users. And the reason why C++ is more commonly used is because even though it's a little bit harder for new users to catch up on as compared to Python, it offers more optimization of the code. So that's why it's better to use on hardware, and that is also why you'd find a lot of people using C++ on hardware, because it offers that kind of optimization, and you have a lot of libraries, optimization libraries, path planning libraries, a lot of these things that you can combine with the code already made by the community to work on with C++.
Right, and also storage and all the rest of things are good in C++ because it's a little, I would say it is not that a high level language than Python. Python is like the most high level language. I mean, all C++ and Python both are high level languages only technically, but if you see that Python is a little more beginner friendly, I would say, rather than
Yeah,
C++.
for sure.
So because of the same reason, C++ has all the storage. Uh, I mean, it does not use much storage than Python. The processing is faster because of how it is related with your assembly line language. Is so yeah, because I think mainly because of that C++ is used, right? Say.
Yeah.
All right. So okay. So thank you so much, Satya Silan, for asking that question. And guys, any more questions do we have in the chat section? I believe. All right. So if you do not have any more questions, well, that brings us to the end of today's session. In case you have any, please feel to write them down. We'll be definitely happy to cater to you guys. And also, as Dr. Shreya Shatra said, if you guys are interested for and working on these such crazy ideas, feel free to apply for an internship, which we are launching. You can apply at spacenova.com/RITP. You can go ahead with that. And yep, Satya, you're also correct. Yep, correct, Satya. What you are saying. All right. All right. Perfect. All right then. Okay. So Mihir is asking another question, and he is the best college for space engineering in the United States. Okay.
I wouldn't say that I'm too familiar with the universities and the courses. So if you're interested, definitely Google. Take a look at what courses they offer, and for sure there are a lot of space-related courses these days. But it also depends on various factors, right? It also depends on how expensive is it, how much. Are they offering the same things that you want to learn? Because there is space systems engineering, there is aerospace courses, there are robotics courses, so it really depends on how you want to combine the subjects to learn. And at the same time, something to keep in mind is that there is all this export control stuff in the US. So maybe you might work in aerospace, but it might be a little harder to find a job there. So that's also something to keep in mind. And yeah, so Google would be to try to research online would be an advice that I would give. Yeah.
Yep. All right. So I think you have. I think me. You have got your question, and yep. I think we not have any more questions in the chat as well. And yep, we have come to the end of today's session also. So once again, thank you so much, our lovely audience, for attending this particular session. Thank you so much for asking your questions as well, and thank you so much for being a part of this entire journey which we are going together. So well, thank you so much for staying with us, and we would see you guys very soon on the 20th of July. Same platform, and timings and everything would be informed to you shortly. So don't forget to follow us so that you don't miss any notifications from us. All right, guys, then that would be it from our end. Again, once again, thank you so much, Ms. Monica, for this live session, and looking forward to seeing you in the grand finale. And if you guys want to interact with her personally, you can definitely do so by reaching the grand finale and interacting live on the August 26th to 28th. That is the grand finale of the Space Science Challenge 2022. Once again, thank you so much, audience, and thank you so much, everyone, for being a part. Looking forward to seeing you again very soon.
Thank you.
Thank you, and have a great day ahead or a great night ahead, in whatever time zone you are. And all right, then, guys, see ya. Ta ta. Bye bye.